Good afternoon, everyone. Firstly, I would like to acknowledge that Noongar Whadjuk people, that are traditional custodians of the land on which we gather today, and I'd like to pay my respects to their elders past, present, and emerging. So I did, in preparation for this talk, I did what every solid researcher does, and I asked ChatGPT. So I asked it, what are the prospects for a Strep A vaccine in adults? And this is what it came back at me with. And as often we find with ChatGPT, it's informative, but it lacks insight. What it highlights, certainly what it's highlighted, is that there's currently no vaccine for Strep A in adults. Most of the vaccine efforts are focused on children, and that Strep A causes a wide variety of different disease presentations. I also asked it, what if there was going to be a Strep A vaccine, would there be, If there was going to be a Strep A vaccine, would this provide cross-protection against group C and G streptococcal infections as well? And for this, the answer to this was complete gobbledygook. It didn't really help us at all. It's a very general response. And then I asked it, what about a vaccine against cellulitis? And it basically told us not very much either. So the purpose of this presentation is to kind of answer these three questions and to put forward an alternative framework about how a Strep A vaccine might make its way through an R&D pipeline and be cost effective in the context of in the Australian context, where clearly the main driver for development of a Strep A vaccine is the prevention of acute rheumatic fever and rheumatic heart disease in Indigenous people. So it's a neglected pathogen, and most of, I'm sure, all the talks you've been shown over the last few days have sort of highlighted everyone's special pathogen is worse than everybody else's. So the global burden of disease suggests that Strep A is the 5th most lethal pathogen in the world, after HIV, AIDS, malaria, TB. And it also shows that compared to those other diseases, the research investment is very low. And for some strange reason, they measure, it's a sort of a pretty macabre way of measuring research development, is the amount of money you spend per death. And on the right-hand side there, you can also see the same thing with, on the y-axis is DALYs, and on the x-axis is R&D funding. And you can see down the bottom on the right-hand side is where RHD, so AKA the Strep A vaccine, sits. So for those of you who sort of maybe aren't aware of what diseases Strep A causes, it causes this very wide range of clinical illnesses. So it ranges from a sore throat, so that's our traditional strep throat, and impetigo. So those are both superficial diseases. And then we have sort of more invasive diseases, such as truly invasive infections. And when I say invasive infection, what I mean is that you've identified the bug from a sterile site. So that could be blood, it could be a joint, or it could be tissue during severe infections. And we also have, Strep A also produces toxins, which causes scarlet fever. And really, again, the driver for the Strep A vaccine development is that there's also immunological consequences of exposure to Strep A, in that it causes acute rheumatic fever and rheumatic heart disease. In terms of where the division sits between adults and children, is that invasive disease, in adults, we really only see invasive disease and cellulitis, skin and soft tissue infections. This is quite different. So the traditional impetigo, sore throat, and acute rheumatic fever, rheumatic heart disease really occurs or began in childhood. So these are the disease manifestations. On the left-hand side, you've got the diseases the illnesses that mostly affect children, and on the right-hand side, those that we see in adults. And I've put up this pretty gruesome picture there of somebody with necrotizing fasciitis due to Strep A, and this is a really horrible disease, requires surgery. It's got a very high mortality rate. And on the bottom there, on the right-hand side, you can see a patient with cellulitis. This is a patient that I looked after. She had actually, this was her 8th admission within the previous 3 years with acute cellulitis of her right leg. The reason I've got group CG strep, or SDSE, as another name for group CG strep, is that in fact it causes a very similar disease presentation in adults to Strep A. That's because it mainly causes invasive disease and cellulitis. And the reason for this is that they're really similar pathogens. 99% genetic homology, and it's really interesting that the group CG carries nearly all the target antigens that are sort of been targeted for vaccine development are carried by both pathogens, by both Strep A and CG. And I'd just like to highlight those little arrows up the top there. There's 3 particular antigens which are the targets of the most likely candidate vaccine is SLO, SCPA, and SPIAD. And so just keep those in mind, because I'll show you some evidence to suggest that group CG not only carries these genes, but elicits immune responses after infection. So what about the epidemiology in Australia of these invasive infections? And this is data from West Australian data linkage by our group, led by Cam Wright and myself. And what it shows is that over time, the incidence across the population for both group CG in the dotted line there and for Strep A is increasing. And you can see that the incidence currently is higher than meningococcus by some margin. You can also see that the age structure for these infections is very different depending on the pathogen. So as I alluded to earlier, the younger you are, the more likely to get Strep A. So young babies get Strep A and invasive disease. And as you can see, as patients age, the burden of Strep CG increases and is higher than Strep A infections in those age groups above 80. Sort of more recently, invasive Strep A infection has really been, it's outcompeting lots of the other sort of star pathogens for newspaper coverage and front page news. And this is the case for Strep A. And you can see that the data there on the graph there just shows really recent data to the end of 2022, which shows even further increasing rates of invasive Strep A. If you happen to present with an invasive Strep A infection, what are the case fatality rates? And this is a meta-analysis done by Jeff Cannon at Telethon Kids Institute, looking at global case fatality rates for confirmed invasive Strep A infection. And what you can see is that as you age, the likelihood that you die from this infection is much higher. And the data from our data linkage study that we did is right up at the top right there. So what that tells us is if you're over 85 and you present with invasive disease, your mortality rate within 30 days is something of the order of 25%. So it's a very high mortality rate. And it's actually even higher for invasive disease caused by C's and G's, Streptococcus. So at the extremes of age, mortality for these infections is very high. What about cellulitis? So cellulitis is a proportion, it's very hard to unpick it, but a proportion of all cellulitis cases, certainly those presenting to hospital, are due to either Strep A or C's and G's. At the present, we don't really know the respective proportions of those things, but our estimates are something of the order of 20 to 50% of all cellulitis episodes are due to one of those two streptococci. And the data on the graph on the left there is another data linkage study that we did, which looks at across Australia at the numbers of patients presenting with their first hospitalisation to Australian hospitals. So what you can see is that as of 2022, nearly 50,000 people presented to hospital with their first episode of lower leg cellulitis. Mostly it's off the lower leg. And again, you can look at the incidence rates for those first episode presentations, which show that, again, the older you are, the more likely you are to have to come to hospital with cellulitis. And by the time you get to your late 80s, your average incidence is 1,000 per 100,000 per year. One of the key parts about cellulitis and cellulitis epidemiology is that you don't just get one episode, and it's very prone to recurrence. And the risk factors for recurrence are all the things you might expect. So age, anything which gives you a big leg, so obesity, lymphedema, diabetes, et cetera, peripheral vascular disease. All those things increase your chance by a factor of about 2. But the strongest risk factor of presenting with cellulitis, these are all hospitalized cases, is prior episodes of cellulitis. So on this graph here, you can see what happens for the patients who've presented with their first episode of cellulitis. And what you can see there, as time moves on, you've got a likelihood of having a recurrence. And so the black line there is the likelihood of your first recurrence. The middle line there is what happens with your after you've had a second recurrence. And finally, the top line there suggests that by the time you've had 3 episodes of cellulitis or 2 recurrences, the likelihood that you're going to present again within the next 3 years is approximately 50%. And with each episode, the length of stay and the severity of the infection also increases. So for the first episode, it's 3 days. For the second episode, it's 4 days. And for third and subsequent episodes, the median length of stay is 5 days. So what's happening is that there's some kind of augmented inflammatory response with every episode. So the end game is, of course, if you have the opportunity, you can prevent primary disease, or if you have somebody presenting with their first episode, there's a huge incentive to try and prevent recurrences because they're very common. So that's what the diseases are. What's the vaccine pipeline look like? And so there are 2 broad approaches to developing a Strep A vaccine. The first is targeting the M protein, and there's a conserved region at the bottom of the M protein where some of the target vaccines, the J8 vaccine is targeting the C terminus of the M protein. And then there's the hypervariable M protein, which sits at the end. And this is how people categorize the M types for the different strains of Strep A which are circulating in the community. The non-M type proteins are highly conserved, and a number of them are shown there. And just to highlight to you, the streptolysin O, so the SLO, and the SCPA and the SPIAD, they're all part of a number of vaccine candidates. But unfortunately, at this stage, there's no active vaccine program which has got past phase 1 trials into phase 2 trials. And so the furthest was a 26 valent M-type protein, which got through to a phase 2A trial. That group are still developing their 30 valent M-type vaccine. And there are a number of other vaccine candidates which are sort of going into phase 1 clinical trials at the moment. And the one that the Telethon Kids and the Australian Vaccine Streptococcal Vaccine Initiative, or ASAVI, based at Telethon Kids and MCRI, have focused on is the GSK multivalent vaccine, which targets conserved antigens, which are non-M type. So the pipeline is sparse. What about the value of a vaccine? And this is a pretty busy slide, but essentially what it shows is we've got the incidence of episodes in the middle panel, the direct cost per person, and the DALYs per 100,000 people. On the left-hand sort of side of the panel are non-Indigenous patients, and on the right-hand side are Indigenous people, and you can see that the ages increase along the way there. Probably the most important thing to sort of focus on here is that, particularly when you look at the DALYs for these diseases, they're very much the burden of cellulitis, which is the yellow burden, both in Aboriginal patients and in non-Aboriginal patients, it actually makes up the big burden of disease, particularly amongst elderly patients. Total healthcare costs are shown there. I think everyone's got their pet number. It's hundreds of millions of dollars. So this is a really interesting graphic which has come from Jeff Cannon and the team at Telethon Kids. And what it shows is the value of a vaccine course. Okay, so basically the cost of the vaccine has to be lower than this to be cost effective. And so you can see on the y-axis there, it goes from $0 up to $1,300. And again, you've got three different cohorts, so infants, children, and adults, older adults. And on the left-hand side, you've got a non-Indigenous cohort, and on the right-hand side, you've got an Indigenous cohort. So just sort of take a step back here. So if you think about the Indigenous cohort, the real value of a streptococcal vaccine is in the young children to prevent acute rheumatic fever and rheumatic heart disease. That's the grey bars on the right-hand panel. So that's the target, and that's the target condition. But if you look for non-Indigenous patients, particularly if you look at the older adults, the real value of the streptococcal vaccine is almost entirely made up of prevention of skin and soft tissue infections, aka cellulitis. And there's also a real value, of course, in the Indigenous population to prevent skin and soft tissue infections as well. The assumption, there are a number of assumptions in these estimates, but essentially what they've got, we've got quite a conservative estimate of protection, although it is quite durable. And the attributable proportion of Strep A to cellulitis cases, again, is quite conservative in that we've estimated just 27% of episodes are caused by streptococcal infections. So of course, the value of the vaccine goes up if the proportion of attributable cases due to streptococci also goes up. This is a hot off the press graphic, and it's just a sort of a little bit of a teaser. And so what we've done here is we've just enrolled patients who presented with invasive Strep A disease or invasive Strep C disease and done acute and convalescent serology testing. And what we've done is we've used a multiplex assay, which is looking at the responses to the GSK vaccine antigens. And I just wanted to highlight, really it shows that things are working as expected. So on the left-hand side, you see patients who've presented with, this is a log scale. And you can see that if you've presented with invasive Strep A, you respond to pretty much all 6 of the antigens. And if you present with invasive Strep Cs and Gs, you can see that the antigens that we would expect them to respond to, so that is the SPIAD, the SCPA, and the SLO have comparable responses. So it kind of suggests that at the very least that a vaccine, well, certainly that invasive Strep Cs and Gs elicits a response against these antigens. A vaccine against cellulitis is, we're not the first people to think about it. And this is an East German study which was published in 1989, where they basically took some heat inactivated streptococci and gave it to patients, and it actually showed quite a reduction in recurrent episodes of cellulitis. And I, just to finalize these questions, the non-chat GPT answers to it is that the vaccine pipeline's accelerating. At the moment, we think that, and rightly so, the target condition should be for childhood vaccination to prevent acute rheumatic fever. But at present, there's no sort of initiative to develop a Strep A vaccine for adults. but there's a clear investment case for that. And as I've shown you, I think there's likely to be cross protection against C's and G's. And I'm very passionate about it. Developing a Strep A vaccine, I see these patients all the time, and they really hate coming to hospital with red legs. So I'll wind it up there. Thanks so much.
So again, if online, if there's any questions, send them to Andrew and we'll get them here. So I've got a couple of questions have come through. The colonisation of strep. So how beneficial is looking at the strep colonisation, and how effective is the treatment of this? So I assume, is the vaccine making a difference to colonisation, and is there any correlation between that and the risk of disease?
Well, that's one of the key secondary outcomes, of course, of the phase 1 trials. So we've developed a number of the team at Asavi and in the RHD program, the TKI and MCRI, developed a human challenge model for pharyngitis, and it'll be that model that is used for some of the early studies for the vaccines, the phase 1 vaccines, and colonisation is a critical secondary outcome. The primary outcome for those studies is the development of sore throat for the human challenge pharyngitis model, but the secondary outcome is colonisation. So we don't know at this stage.
Does the way the PBAC in Australia devalues or discounts vaccines means Australia gets vaccines later? And are you worried that our approach to this is going to put us behind the rest of the world?
No, I don't think we're going to be behind. I think there's not many groups working on a streptococcal vaccine. There's really the Asavi group in Australia and a few other groups around the world. So I don't think, certainly in the research pipeline, we're not behind.
Okay. Okay. So to the last of the questions, you've got a minute or so if you want to add something, or what's the next question to ask GP chat? And when do you think it will be useful in your research?
This is a ChatGPT.
Yeah, ChatGPT.
Well, I think with all these things that it's only as good as the information that's going into it. So I guess the key factor is to try and understand. There are some gaps in knowledge for us. Certainly for the cellulitis vaccine, the key gap in knowledge is understanding what the attributable proportion might actually be vaccine preventable. And for those of you who are clinicians, or for those of you who aren't, basically we very rarely find out the pathogen. So people present with a hot red leg, they're sick, they feel unwell, and they get better with antibiotics. But usually we don't find the bug, so we don't know. So we're going to have to be a bit more crafty about how we actually work out which pathogens are causing these infections. So that's the key gap. And once we have that, then ChatGPT will give us a much better answer.
Thank you.